Hi everyone, welcome to today's video on solution to this indices problem. If x is equal to this and p squared minus q squared is equal to r cubed, show that x cubed minus 3rx minus 2p is equal to 0. First of all, let us go through the laws of indices that we know. Let's say we have am times an. With multiplication law of indices says add their powers, so that if a 3 and you multiply with a squared, you just have a 3 plus 2, which is a 5. Division law of indices, am divided by an will give us subtract their powers, so we subtract their powers. So if we have a 3 divided by a squared, you have a 3 minus 2, which is a, or is equal to a raised to power 1. Power index, if we have am raised to power n, all you have to do is to multiply it am times n, so that if you have a 3 squared, it will just give you a cube times a cube, which is a 3 plus 3, which is a 6, a raised to power 6. Also, the fourth one, if we have a fraction a raised to power 1 over n, for instance, will give us nth root of a, nth root of a. It will give us nth root of a, so that if we have, this implies that if we have a raised to power 1 over n times m, it will now be nth root of a, or raised to power m, and it's not ordinarily a raised to power m over n. The next one is this: if we have a raised to power 0 times a raised to power m, you know from multiplication law of indices that it will be 0 plus m, and it's equal to am. So this implies that a raised to power 0 is equal to am over am. A raised to power 0 is am over am, which is equal to 1. Also, if we have that for negative, if we raise to negative power, a raised to power this, we can easily say that it is a raised to power 0 minus m, and which is equal to a raised to power 0 over a raised to power m, according to division law of indices, so that we have found out that this is 1 over am. So with all these laws now in place, we can easily now try to solve this, to show that when we substitute all these things in this equation, we will get 0. So let's start. So we will now put this here. If we put it there, we will have an equation like this: p plus q raised to power 1 over 3, since we now know it, plus p minus q raised to power 1 over 3, all cubed for this one, minus 3r is, r will be cube root of this, r is p squared minus q squared 1 over 3. Then x is this, x is that, it's p plus q 1 over 3 plus p minus q 1 over 3. That's x, put in a square bracket. So we have got this, then minus 2p, minus 2p. So what we will now do is to open this bracket using Pascal's triangle. Remember our Pascal's triangle that we did before: 1 1 1 2 1 1 3 3 1. So since it is raised to power 3, we'll stop at 3 and we just write it like this. We stop at 3, so we have P plus Q 1 over 3 all cubed plus P plus Q 1 over 3 squared, then P minus Q 1 over 3 plus times 3 because of these coefficients, times 3 times 3. The next one will be also 3, this coefficient, times P plus Q 1 over 3 P minus Q 1 over 3. This one is all squared, so that every time the powers will be, remember this is 1, so that the powers will give you 3 at every time. 3 3 3 plus 1, the last one, and which is P minus Q 1 over 3 all cubed minus this whole stuff, this thing. I will just write it for now as 3rx minus 2p. Subsequently I will bring it out. So for here, if we open it up, you see that this is raised to power 3. If we use this law, it will be m over n, that's 3 over 3. So 3 over 3 is 1. So this then boils down to P plus Q. Also, if we go here, we see the same thing, so that this one boils down to P minus Q. So that if we now add P to P and Q to Q, we have Q will cancel Q, but we have 2P. Remember, there is a minus 2P somewhere. 2P. There is a minus 2P in our equation. Look at it. 2P minus 2P. This 2P, this one, and this one. 2P minus the given 2P. This other one I have cancelled. Plus, you now write 3 into P plus Q squared P plus Q squared raised to power 1 over 3 into P minus Q 1 over 3 plus 3 into P minus Q squared raised to power 1 over 3 P plus Q raised to power 1 over 3 minus 3P, 3Rx. I will be writing it like this for the meantime. After we revert back to this. So we have it to be, we now open this bracket. This one cancel. We now open this bracket. If we open this bracket, remember this one is with this and this one is with that. If we open this bracket, we have 3 into P squared plus 2PQ plus Q squared into P minus Q all raised to power 1 over 3 plus, for this one, 3 into P squared minus 2 P squared minus 2PQ minus plus Q squared P plus Q 1 over 3. That's all raised to power 1 over 3, but let me just do it like this. Minus 3Rx That's what we will have. So that if we use this to multiply this, multiply that, this multiply this multiply that, this multiply this multiply that, we will have that. If we do that, we will have that 3 into p cube minus p squared q plus 2 p squared q minus 2pq squared plus p pq squared plus pq squared minus q cube, and let's cube that. Yes. Then 1 over 3 plus 3 for this one. We open it up again just this way. If we open it up, we have p cube plus p squared q minus 2p squared q minus 2pq squared plus pq squared plus q cubed, all raised to power 1 over 3. Remember, minus, let me write it here, minus 3 rx minus this 3 rx. So we now see that we can factorize this equation. To factorize it, we'll have okay, this one and this one can go, this one and this one will go, so we'll have it in this form: 3p cube plus p squared q, this one and this one, minus pq squared minus q cubed 1 over 3. Then let me just, then plus for the second one, plus 3, the same thing, this one and this one can go, so we have 3p cube minus p squared q, this minus this, minus p q squared plus q3 minus 3rx. Okay, so we can now factorize. If we now factorize, we'll have, we'll have p squared into p plus q, p squared plus q. So something will be here is q squared minus so 1 over 3 plus 3. You come over here, the same thing squared, you factor out p minus q, so that you have this, you put it the same thing inside this bracket, then q minus q squared, get this, yes, 1 over 3 minus 3rx. So that from here, if we now just get that 3 into p squared minus q squared, let me just, because you have in the bracket p plus q, but let me just put the fraction here in this immediately. So that's what you have for this one, plus 3 into p squared minus q squared, the same p minus q Let me put the fraction also here according to that second law or third law, so that this is cube minus 3rx, so that if we factor out this one, we will have if we factor out this one, we'll have 3p squared minus q squared 1 over 3 into p plus q 1 over 3 plus p minus q raised by 1 over 3 minus, let's go back because of space, let's go back and write this thing out normally. Let us write it out normally. This one is this. Look at it here. We're going to write this one out and inspect. So minus, remember we're writing this one out, so if we write it out, let me write it out here. You have minus 3 into p squared minus q squared 1 over 3 into p plus q 1 over 3 plus p minus q 1 over 3. That's what we have. So we can, of course, you see that what is on the left, what is here is what is here, so it's 0. But if you factor it out, you see that 3 into p squared minus q squared 1 over 3, then p plus q 1 over 3 plus p minus q 1 over 3 minus this whole thing, p plus, because we have brought this one out to factor it out, so p plus q 1 over 3 plus p minus q 1 over 3. So you see that this one will cancel, this one is 0. 0 times this is equal to 0. So it has been proved that this equation, if we have this, that this equation is equal to 0, following what we have done. So thanks. Please subscribe and click on the notification button so that whenever we post new videos you will see it. Thanks and have a nice day.